Howdy everybody. Today's video is going to be all about building a roof rack for my van. If you've watched my channel before, you will know that a little over a year ago I installed some Lightleaf solar panels on my van, and now I'm actually swapping them out for a different lightweight solar panel option. That topic and what inspired the swap will be covered in a different video that may or may not have been posted already. Once it is, I'll link to that video down below, or there'll be a link that pops up on the screen, but I'm holding off saying too much about that because tariffs, and I'm not actually sure if either of these two solar panel options are available anymore. So this video will be just presenting the roof rack build, and there's sort of two portions to this build, the first being the actual rack portion, and then building a carbon fiber fairing for the front. The roof rack went quite smoothly, and the fairing, being my first foray into carbon fiber, went basically the opposite. To build the roof rack, I'm going to be using Moxitec. It's an aluminum framing system that relies on these like right angle extrusions or just these regular rectangles, and then you combine all the parts using either these like hammer fit connectors, or they've got some other connectors we're going to be using that hammer fit on one end and then use screws on the other end. I think if you've got an application in a van where wood isn't appropriate, and you're tempted to maybe use 80-20, I think for like 99% of those applications, Moxitec is plenty strong. It's like 30% of the weight compared to 15 series 80-20, and it's also cheaper. So I just think in a van, Moxitec is a great solution. My order from Moxitec for all the parts I need for this roof rack is right around $250 before shipping, so way cheaper than any like aluminum roof rack system out there. And then if you add the other things, like we've got a little bit of adhesive, we've got some other little brackets we're gonna need. I think I'm about $325 in for this entire roof rack. If you did get like the painted extrusions and maybe screwed up a couple of things along the way, I don't think this roof rack would cost you any more than maybe like $500 total. So it's cheaper than like any other roof rack I've found on the market. And it weighs right around 25 pounds, which is also about half of what the next lightest roof rack I have found available. Is this roof rack going to be as functional as some of the like $2,000 offerings out there? Definitely not. This is a very like specific function designed roof rack just to hold solar panels. Those other roof racks, it's easier to bolt a bunch of stuff to them. So if you want a roof rack that looks like ultra rugged and you've got like other ornaments on your van, I don't think this is going to be a great system for you, but like 99% of vans I see, they've just got some solar panels up there. The roof rack I'm making today, all it's got to do is hold solar panels, so it's going to be as low profile and as lightweight as possible, which I think is just like a much smarter idea for how the majority of vans get used. So with that little preamble out of the way, let's get these solar panels up on the roof, see how everything's gonna lay out together, and start getting this roof rack assembled. So given the specifics of my exact setup, meaning it is pretty unlikely that you are installing these same solar panels onto exactly this same model van, I don't think it would be very helpful to present this project as a step-by-step guide with any exact dimensions. So rather, let me just give you the basics and some useful tips that I've learned after working with Moxitec. All right, let's use a little pad technology to make sure we're both on the same page here. If we imagine the van from like a bird's eye view, kind of the shape of it, we've got a windshield up here. And then from the factory, there's a couple mounting rails that run lengthwise down the van. So, and then the only other thing I've got on my van is a ceiling fan back here. So we're going to take a couple of the Moxitec right angle extrusions, make a couple of rails that run like this, and then we'll make some crossbars out of those rectangular extrusions that run like this. It's pretty tight clearance for me to get all these panels stacked in front of my ceiling fan, so the front of my rack does actually extend just slightly past the end of the factory rails. And I've got these funny looking tails back here you'll see in the finished product. And those are basically because I have some vague plans to make a little shade awning. And then I'd add a couple hooks to the end of it back here into the Moxitec. So I've kind of left those tails on there for a future project. That may never happen, but pretty simple what we're building. So let's get into it. The roof on this van, and basically any camper van you might be converting, has a bit of an arc to it. So I spend a good bit of time trying to figure out how high the side supports will have to sit above the factory rails to clear the center high point, that center rib. My goal here is about 1/8 to 1/4 inch of clearance. We'll come back to how these tight tolerances require some accommodations later in this install. Building things with Moxitec is pretty self-explanatory, even if you've never worked with it, but let me give you some pointers that have helped me. There are numerous brackets on the website, and they are all specifically made for a certain kind of joint. So compared to 80-20, it does take some foresight. You have to order the right bracket for the type of joints you will need. The brackets I use a ton of are these screw connected T-brackets. One end is hammered into the tube and the other is attached with 2 screws. There are 2 variations to this, one with internal screws and one with external screws. The internal screws look cleaner, but if you had to adjust anything, you'd have to dismantle the assembly to get to them. Oh yeah, and quick note about screws, Moxitec sells Phillips screws for this, and I have a mild hatred for Phillips fasteners, so I just ordered some square drive screws of the same dimensions from McMaster. Anyways, I use the internal screw brackets to hold all the crossbars in place for this project, except one which we will talk about shortly. Couple quick notes about the end caps that Moxitec offers that really help make this project look nice and finished. Whenever building something with this tubing, I try not to install them until basically the very end, as it's nice to be able to blow out all the metal shavings from any holes you may continue to drill. So coming back to the crossbar that I said I used a different bracket for, that is because when buying Moxitec tubes, the longest length you can get is 94.5 inches. And coming back to our sketch here, this length, greater than 94.5 inches. So we've got to splice this together somehow. So at this point right here, we'll be using this bracket so that these sides are essentially one continuous piece. This bracket connects 2 of the L pieces lengthwise and has a T connection to a rectangular piece. Keep in mind though, this will slightly change the length of the crossbar here. If you look at those screw-on T connectors, once you screw them on, they have this little lip, like a little flange that sits on top of the tube you just screwed into. This T bracket though, however, does not have that flange. It sits flush with the right angle lengthwise pieces. So what this means is for this crossbar, you have to add 1/8 of an inch on each side or 1/4 inch to the full length of it. These small details are pretty intuitive after you have done this once, but if you don't notice this little difference, you'll essentially waste this crossbar because it will be too short for this application. And then the last bracket I want to talk about are these aluminum corner reinforcement connectors that I decided to use on the front 2 corners of this rack. My pseudo-engineering mind and its concern in designing this rack is obviously uplift when driving at high speeds. These panels could essentially become big wind sails, so I want to make sure these front corners are reinforced. Even though I'll be making a fairing that should prevent any of that wind getting below it, it's still just like a concern that seems pretty logical as like a mode of failure in this design. So these corner connectors I use at the front for reassurance. So for this build, you may have noticed that there's a couple shots where the Moxitec is silver in color, and in most of the shots it has been painted black. I went with the unpainted version, but as I mentioned earlier, there is a black painted version. Now that I'm editing this video, they have actually introduced a clear anodized version as well. Going with the unpainted version is considerably cheaper, but for a customer, I would have just gone with the pre-painted or anodized version. It is a very time-consuming process to prep and paint all the pieces. For that paint, I used Total Boat aluminum paint, which has a good reputation, but I've not managed to get good results with it. I bought some for another project for a customer. I tried to brush it on, but it actually looked so badly after the first coat, I aborted before the customer ever saw it. So for this project, I had most of a can left over and I thought I'd try spraying it. It did look good, but it scratches super easily. I know people get good results with this stuff, but I can't seem to. My advice though is if you value your time at all, get one of the pre-finished versions or just accept the raw silver aluminum. So the last major thing to cover is installing rivnuts into Moxitec. The solar panels I'm mounting will be held down using M6 rivnuts, and the whole rack is held to the roof using M8 rivnuts. Installing both of these is pretty standard, but you have to use the right installation tool. And by that, I mean your installation tool has to have the proper thread stem length. This isn't really a tool modification, but I'm not sure you can do this with all rivnut installation tools. Let me explain. The tool I use for M6 rivnuts is a pneumatic gun, and if you use one of these a lot, you will know periodically you have to replace this bolt as the threads slowly degrade and deform. It came with this length, but that would be too long since it would bottom out in the tubing. But you can just use a different length bolt, and that lets you use the tool in shallower cavities like the Moxitec. For the M8 fastener, when using stainless steel rivnuts, I prefer to use this hand-operated style as I've had some trouble stripping the relatively soft threads. This tool again came with this length bolt, but if you go with this one instead, you have just enough room for the installation. Of course, make sure you don't use too short of a bolt, as you do want most of the Rivnut threads engaged so you don't strip or deform them. And I think that's about all the basics to build a rack like this. The finished frame is a big assembly, to the point I found myself balancing out of the frame of the video to hammer it together. Don't tell my girlfriend about me climbing ladders like this, but honestly, who has time to walk across the shop and get a bigger ladder? So before I lift this thing onto the roof, it's time to weigh it. So let's talk about how much this whole project weighs now. The finished frame weighs just under 17.5 pounds. Then the hardware to secure everything, which consists of some angle brackets, some M8 bolts, washers, anchor plates, and M6 bolts and washers, weighs 4.1 pounds. And even though we haven't talked about it yet, the fairing will be right around 2.1 pounds. That weight includes some plastic spacers that we'll be talking about shortly, bringing the total assembly to right around 23.7 pounds. There are a couple more small things I know I forgot in this, mainly that's some adhesive and then a little bracket I'm about to talk about, so I'm just going to call it 25 pounds. For comparison, the lightest roof rack kit I can find to buy weighs 50 pounds. All the other ones weigh 60 pounds, 70 pounds, or even more. Owl Vans even calls theirs light. Now that's a funny joke, guys. So let's get this thing on the roof. Circling back to the tight tolerances between the roof and the crossbars, and knowing that I'll be driving at interstate speeds or in the winter with snow piled on it, this thing will be subjected to all sorts of forces that may deflect it what I'd call a non-negligible amount, meaning the crossbars with maybe only an 1/8 inch of clearance and the roof could come in contact. So to prevent this causing any rattling, I'm actually pre-caulking the gaps. This isn't what I'd call a structural concern, just one to prevent annoyances. And on the front crossbar, where there is no rib close to it, I'm still concerned about uplifts as well as downward sag from snow loading. So I use a small angle bracket that is screwed into the crossbar and then glued to the roof with some flexible adhesive just to give it a little help. Again, I don't think this thing is going to fly off or break, but these little measurements are there to help prevent any movement. All that's left now is to tighten the brackets to the roof rails. I didn't address this earlier, but for the brackets, I used some leftover 15 series 80/20 corner brackets. And for the anchor plates, there's just some anchor plates I made a while ago that actually held the original brackets that held the original solar panels on this roof. They are simple to make, just some stainless flat bar stock with some M8 threads tapped into them. The original brackets I made required 2 bolts each, but for this rack, I'm cutting most of them in half because of how the brackets are spaced. At the very front and at the very back of the rack, I do have 2 fasteners closer together, and that again is like my pseudoscience or pseudo-engineering mind, trying to guess what part of this rack will see the most forces. So now let's talk about the other part of this project, which was building that front carbon fiber fairing, and that was actually happening concurrently to this roof rack build. I'm pretty happy with how it turned out, but I'm not proud of how I got there. This whole process is actually pretty simple, but keep in mind that the nuances to master it, like any other craft, would take years to perfect. In a nutshell though, you buy some carbon fiber cloth and you wet it out or saturate it with resin or epoxy and you make things. The layup you are making usually requires multiple layers of cloth, and the whole object requires a mold so that you can put the cloth into it to make the object. This was a pretty intimidating project for me, especially since a fairing like this is a pretty big first part to experiment with. If you are thinking of doing something similar, a better first carbon fiber project would have been something smaller, or perhaps a flat sheet instead of a 3-dimensional object. I knew these things going into it, but I decided to go for it anyways. If you are curious about making things with carbon fiber, here is the video I found that basically seemed most applicable to a simple assembly like I was making. So let's start this process. Knowing that I might fail at this, I bought the cheapest carbon fiber cloth I could find. There are many different weaves to choose from. This can be a little overwhelming, but from some reading, a good all-around option is a 2x2 twill weave. On Amazon, you can buy it in long strips that are pretty cheap, and for a fairing like this is a great option. For the epoxy, I used West Systems 105 with the 207 hardener. This is like their clear hardener, and the general epoxy I use in the shop, so it was nice to already have this and not have to buy any for this project. So then to make the mold, I needed to kind of figure out a rough template of what this thing is going to look like. This included getting some angle approximation up on the roof, as well as using some paper to imagine what the side profile will look like. Nothing too complicated, but it's sort of that game where the bigger you rough it out, the more material you waste, but if you make it too small, you waste all of it. Here's my highly accurate drawing, 30-degree angle at the bend. The final piece will be about 3/4 by 4 1/4 inches, so I make my mold for a 2x6, and it's 58 inches wide. To make the mold, I decided to use some melamine. It's a pretty cheap material, and in some very limited like epoxy wood slab stuff I've done, it's a great option to kind of contain those projects, and it releases easily from the epoxy. Pretty self-explanatory here, gluing up the long piece for this fairing mold. I use some tape on the back side of the joint to keep things nice and tight, as well as some clamps on the front side to hold things in position until the glue dries, and then I add these side pieces for the corners of the fairing. One thing I do want to mention is you have to use some sort of mold release so the epoxy doesn't bond to it. I ended up using this paste, which is popular in the carbon fiber research I did, and then sprayed this stuff over the top, which was recommended to me back when I was looking into wood epoxy projects. I had no issues releasing my part from the mold after my glue up, but perhaps it actually made it too slippery, which I learned and we'll talk about shortly. So let's talk about that glue up. Given how much carbon fiber cloth I had and where I think the strongest areas of this part need to be, I decided to go with the layering where the bottom and top layer are made out of complete sheets, and I used some partial pieces to reinforce the corners and the big long bend. When I talked about my mold being too slippery, I learned this when I would try to get the cloth pressed into the epoxy, and when trying to squeegee and squeeze all the air out, I was having lots of issues of it shifting around. Anyways, I squeegeed and rolled and tried to get it perfect, but once it cured and I took it out of the mold, I realized I didn't get all the air out, especially along this seam. I did some preliminary shaping of the fairing and then tried a few fixes that, if anything, made things worse. Being epoxy, this process dragged on. Every attempt required waiting for the epoxy to cure. I first tried to fill the gaps along the crease, but this just chipped away as bonding new to cured epoxy isn't very strong. Then I decided to vacuum bag the piece in the mold again with more epoxy, and this did help fill the corner and the edges, but ended up trapping air bubbles in the surface. Oh my God, even worse. Which then I tried to fill by just letting some epoxy self-level, but again, it wasn't a very strong bond. All of it was creating more and more issues, and once I went to sand those thin puddles, it was a waste of time as I ended up sanding into the fibers a bit. I was pretty scared I would just have to trash this whole project, but I decided my only hope was to buy a little more cloth and just add an extra layer to the outside. So back to the mold I went. This time I laid down that first layer of cloth and I tried to really squeeze all the air out of it this time. Then I pushed the pre-made assembly into it and then used all the clamps I could find to try to make sure this was a nice and tight press.
Sick.
And sure enough, it worked. It wasn't flawless, but as good as I needed. Finally, I was at a point to fine-tune the fit. For cutting the carbon fiber, I used a cutoff wheel on a Dremel for the corner areas, and then I used a router with a pattern bit using a bent strip of wood to make that long front curve. I will say this front curve took numerous iterations of taking just a little bit off and testing the fit. I was trying to strike a good balance of some pressure down on the roof, but not so much to deform the part. In the end, I ended up using some thin plastic spacers between the fairing and the roof rack. Bringing it up that 1/4 inch helped me actually not have to make that fairing too short in the middle. All that was left now was to add a piece of edge trim and a gasket, but before that I decided to buff some car wax into it. The West Systems epoxy is supposed to be UV resistant, but this seemed like a nice touch. Unfortunately, the wax packed into the tiny air bubbles in the surface and made it look worse. Doesn't matter as the wax will degrade, but it always sucks to do something you think is helping only to have it look worse. Hindsight is 20/20. Anyways, I added the thin piece of edge trim and a rubber D-gasket on the bottom to close the gap, and needless to say, I was very happy to finally have a functioning product, even with those pesky little wax spots. Looking back at this project, it was very clear to me I should have started with a smaller, simpler project first. I was just impatient. The fit and shape turned out pretty good, but could be improved. I really didn't want to cut off more of it because my original goal is that this would actually have the same curvature as kind of this factory cutout here. But at this point, I've already got a little bit more of a gap towards the ends here than the center, and I don't want to keep chopping this away. I think in the eventual like 3D world, if you're going to produce this, this can't be a flat surface to achieve that. This has to have a curve while this top part stays flat, and that three-dimensionalness is a little bit past the capabilities of my MDF mold setup. But anyways, pretty happy with how that looks. And for those carbon fiber wizards out there, I am well aware of how fugly and distorted my weave is in a lot of areas. That's what I meant when I said earlier about the nuance of all of this. There are so many small things to account for to be good at something, and I think this part is passable structurally for what I need, but not much else. So the last portion of this whole story is obviously the panels that are mounted to this roof rack. I've got 800 watts of solar now on my roof, and these panels are from a company named Roboteos, and I'm actually not sure if these panels are ever going to be available anymore. I am super excited about them, so please watch the video that should be out shortly about these, or may already be posted depending when you're watching. Overall, this was a fun project for me, and it's always fun to try new things. I did have some frustrations, but I think it turned out pretty good. If you are also planning to just mount solar panels on your roof, I think this is a much better option than any of those kits that are available. It is truly cheaper, lighter, and lower profile than anything I found available. It does take more time, but I think if you've made it through this video, you probably are here for some DIY inspiration, so you know that's the trade-off when doing something yourself. You can make a better product, but it does take more time. Anyways, as always, thank you so much for watching, and I'll see you guys next time.